All right. Hello, good evening, good morning, wherever you are joining in from. Welcome to Winter Hackathon 2025 closing session. Um, what we would like to do today is this celebration, this event is for you to celebrate your hard work for last 8+ weeks. Thank you for participating in Women in Big Data's Winter Hackathon cohort. We are extremely happy and excited to host you all today. And we would like to hear more from you, your experiences, and your stories. With that, this is the agenda that we would like to have. Okay, so we would go over with Women in Big Data's mission, the overview, what we do, why we do here at Women in Big Data. We will also talk about the hackathon program of which you all became part of and what particular challenge for this cohort we chose, what we selected, and what all of you worked on in partnership with our sister organization, Women in Data Science, WIDS. I will be introducing our session moderator for today, Stuti. You all have met her. We will then have team introductions, and then this is the order. We will have all our teams present their findings, their journey, and their experiences. We will have a short Q&A session at the end and closing remarks. All right, so our mission to foster careers, develop women leaders in the field of data, to bring data equity, to support, to nurture women leaders, beginners, whatever state, phase in your career journey you are at. uh, Women in Big Data is here to support you through our various programs, knowledge sharing, development workshops, hackathons. Of course, that's the program we are all here for. A bit of our history, we started back exactly 10 years back in 2015, right here in one of the Fortune 100 companies in Bay Area. And our co-founders were here back then in Bay Area, where it all started with about 15 members. Now, in fast forward 4 years, 2019, we became a nonprofit organization with the aim and passion for global expansion and taking the small seed of 15 members that they planted here at one of the company's office room in Bay Area in 2015. The focus and the mission, the charter that the Women in Big Data co-founders started with basically connecting like-minded people, like-minded women who are looking for guidance, who are looking for training, who are looking for mentorship in the field of data. Then it became anything related to data, machine learning, data science, now of course generative AI. Through workshops, trainings, hackathon, technical programs, certification, now we have Data Camp partnership through Data Camp Donates program. Mentoring program is a critical pillar of Women in Big Data's initiatives. And as part of that, we also have leadership training. As our organization, that little seed started growing through the that's happening, we are now present in 6 continents, 50+ global chapters, 250+ trainings have been conducted so far, 20+ thousand members and counting. And as you could see, the purple dots are growing every day, and pretty much every night we are covering all time zones. Who we are, this is our outreach. Again, as I said, we have now 22,000+ community members. Around 600 participants have participated either as a mentee or mentor through our mentoring programs. 120+ volunteers like you and me, have donated, have worked 10,000 volunteering hours for Women in Big Data over the past 1 year. We have around 70 to 75 learners who have completed or on their path to complete a particular certification through our Data Camp Donates program, which is our training wing, and then 2,500 podcasts downloads. We have another program called Women in Big Data Podcasts. Um, so, what is the spread of our member community? Um, like you can see, we have folks from data science, data analyst, machine learning, and data engineers, of course, with software engineering background. That constitutes a major part of our membership community. With the three main pillars that kind of binds us together, people come to us. People became part of Women in Big Data for networking, learning from peers, different training and mentoring sessions that we offer. 70% of our respondents or the community volunteers, they prefer small to medium size programs offered to catering their particular interests, their particular career aspirations, career choices. And we have people from all walks of life, from all phases of their career, students, early career, professionals, mid career, as well as senior leaders, mentors joining hands as part of Women in Big Data. Some of the events, these are like some pictures, some snapshots that I could gather from like a library of our knowledge base that we have, and these events are like growing. They are happening every day, every week, every weekend. Some chapter, some community outreach event is happening. Speaking of Bay Area, my home chapter, last Saturday, and Stuti can definitely share more on that. We had a fantastic event in person. Anath is here. They could definitely talk more about it. So unfortunately, I couldn't get that picture in time for this slide, Anath and Stuti, but these are some of the glimpses from around the world through our Women in Big Data chapters. What we do, I have covered most of these pillars already, but this is where it kind of boils down to six main pillars: soft skill development, technical skill development, leadership, mentoring programs, and again, hackathons and technical training, community growth and awareness, outreach through networking. Now, coming to the hackathon, that's why we are all here for. These are some of the past hackathons that we have successfully conducted. Now, this year, I'm very proud to share that we started vertical initiatives as part of Women in Big Data. And why this news I felt important to share today. Women in Big Data's AI for Healthcare initiative. Again, it's a global initiative spanning all Women in Big Data's chapters worldwide. The purpose is accelerate equity for women in AI and data in healthcare. At the bottom of it, you could see the foundational services, the foundational initiatives that Women in Big Data has and supports through training, podcasts, mentoring, career counseling, networking events, and of course, hackathon programs. On top of that, we have started this specific initiative for healthcare, where our members, our community partners would develop, would connect in healthcare industry for again, mentoring, networking, and AI related initiatives, learning, career growth in healthcare. Now, you all know you have worked on a very interesting challenge topic this year, which Stuti will be covering very soon. And with this initiative, this vertical pillar initiative at Women in Big Data, we are very happy to offer challenge topics which are related to healthcare, but we will not stop just there. Including along with healthcare, we will have all different types of industry verticals and domains specific challenges that we would select, and we would try to offer that through our different hackathon cohorts, going forward. So I just thought of sharing this great initiative that we recently launched as part of Women in Big Data's next initiative. Um, so who are we? Specifically talking about the Hackathon initiative here at Women in Big Data. That's me under the gray bluish clouds. My name is Rupa Gangatirkar. I'm a AI ML solutions architect and data scientist at Siemens EDA. That is electronic design automation. That's what it stands for. People who are not familiar with that acronym, and it's mostly designing tools, software for semiconductor industry, semiconductor chips. So that's the domain I come from, and that's where I work. We have Stuti as our lead data scientist from Samsung. She is a critical support for Women in Big Data's Hackathon program. She is serving as technical advisor and coordinator on our team. Shala Arshi is co-founder and board member of Women in Big Data, and she's also the Hackathon executive sponsor. And Tina Tang, also co-founder and board member from our very own Bay Area, and also our that golden bridge between women in big data and women in data science, our sister organization, with their Datathon programs and their uh, hackathon initiatives is what we are collaborating with. And Tina was the person who connected women in big data and women in data science for the Datathon initiative. Now, okay, now the spotlight is on my friend, my partner, and our hackathon technical advisor, Stuti. Stuti is lead data scientist at Samsung, focusing on establishing and enabling data science framework, tools and technologies for field quality and reliability solutions at Samsung memory products. She has about 6 years of AI and ML experience building solutions for consumer electronics industry. By the way, a little anecdote that Suti and I worked for the same company coming from semiconductor industry. Not at the same time, but we share our, alma mater when it comes to our semiconductor experience. Um, Suti's interests are in data science, of course, data engineering, machine learning, system architecture, design, and technical leadership. She's passionate about solving complex business challenges through data-driven decision making. Stuti has been an active member and participant for hackathons, different types of challenges that she was herself as a mentor. She has led teams for Women in Big Data's hackathon initiatives in the past. So she comes with great and exactly suitable aligned experience to help all the hackathon team members joining our cohorts. So with that, I'll hand it over to Stuti. So Stuti, here you go.
Thank you, Rupa. That was quite an introduction. But I really, really enjoy working with all the women in big data leadership and especially Rupa. She has been championing our hackathon program for the past couple of years. So, really excited and happy to be part of this initiative. Okay, so let me share my screen and get started with today's presentations with all the teams present here and would really like to learn more about the work they have done. Um, so I will briefly introduce the challenge that we had this year. So since last year, Women in Big Data has been collaborating with Women in Data Science. It's a sister organization. And they have been launching this Kaggle Data Science Challenge globally. So anyone in the world can participate on Kaggle for this challenge. It's open to public. And so Women in Big Data has crafted a program around this challenge. However, the main objective for starting this hackathon program was because we want to encourage people to learn hands-on data science skills. We understand that data science is a very evolving and a very upcoming field, but there is something new coming out every day. So just to be on top of this field and learn something new, it's really crucial to have some hands-on experience, side projects, build your portfolio and your resume, as well as work on a real-world problem and a data set, which is quite messy and quite noisy compared to theoretical or clean data sets. So who can join this program? I think this is open to all Women in Big Data members and all chapters worldwide. So if you are an industry expert, you can join this program as a team leader or a team coordinator, become a team member if you want to actually work on the challenge and work on making some meaningful uh, algorithms and models for this challenge. And it's actually open to people at all career levels. You can be a beginner in the field. You could be wanting to switch into the data science space, or you could be a professional wanting to advance your career in this field because there are enough tools and resources to get started with the hackathon. And it's a totally 8-week program. So there's enough time to ramp up and learn more about the challenge and the data set. So this year's challenge in particular um, was a data set which was launched by the Healthy Brain Network of the Child Mind Institute. And the problem this year was to build a multi-outcome model to predict the individual's sex as well as their ADHD diagnosis using fMRI brain imaging data, along with key data set, key data about the individual's background and socio-demographic information. So this is a very important challenge because if you look at the data set also, you can notice that there is an imbalance in the data set between males and females. There are less diagnosed ADHD females compared to males, right? And they really want to build a machine learning model which can detect the onset of ADHD early on based on all these key factors and data points, as well as remove the bias from detecting ADHD, being able to diagnose ADHD regardless of the gender, right? And that is the reason this challenge was very important and solving a real social problem. The timeline of the hackathon was from March 1st was the hackathon kickoff. Before March, I think the WebD applications opened sometime in February, and we did some participants vetting and formed teams, as well as found the team leaders to mentor these teams. And then we kickstarted the hackathon on March 1st. The end of the hackathon was April 30th. This deadline was given by Women in Data Science and the Kaggle platform. So everyone had to get in their submissions by April 30th. So congratulations to all the teams here, all the 5 teams. Part of this cohort this year was able to successfully complete this challenge and make their Kaggle submission. And I think overall, this hackathon gives a really unique opportunity to network with a lot of like-minded people in this field, as well as work on a team project and build those connections with your teammates, as well as solve a unique data science problem with a real-world data set. Okay, so with that, we are going to get into the teams for this hackathon. I think for this slide, we just want to call out all the leaders and all the mentors who have really helped us throughout this hackathon duration. And really, all of the people here on this slide really inspire me. And they are examples of being very proactive and very, dedicated to help people grow in this field and learn and share knowledge. So from the Bay Area team, we have Anat here. Anat Zohar, she is also the Bay Area chapter leader, and she leads the hackathon initiative. We have 2 teams from the Bay Area, Brainstormers and the Bay Brains. Sri Ram is the team lead for the Brainstormers, as well as Anoop. He has been leading and mentoring the Bay Brains team. From the India team, we have the India chapter director, as well as the hackathon chapter leader, Soumya, and the India team leader, Aditya Kumar. St. Louis team unfortunately couldn't make it today here. but we do acknowledge and appreciate Usha and Zihan, who have successfully completed this challenge. And from Data Camp Donates, we had one team participate this year, and the team leaders were Ravi and Shividya. They helped the team to complete this hackathon challenge. So, a huge shout out to all the people here, and thank you for making this hackathon happen. Really appreciate all of your contributions. With that, we will dive into the team presentations. So before we jump in and give the stage to our first team here, just a reminder, if any of you have any questions, just put them in the chat window. We will take questions at the end of all the team presentations. Just be mindful of that, just so not to interrupt any team. With that, I think we can give the stage to Lucy, Niyati, and the whole Bay Brains team, Brainstormers team. I think you guys can get started. I can control the slide deck, so let me know if you want the next slide.
So I
Lucy,
think one of our team members is sort of locked out of the meeting, Aya.
okay. I think Rupa, can you admit her in
Yes,
the meeting?
yes, I'm trying to unlock the meeting and I will do that.
Sounds good.
But go ahead.
She's the first presenter.
She was, yeah.
Yes,
Okay.
she is. Can we wait for a minute until she
Yeah,
gets admitted?
let's wait for her. Let's wait for her to get in the meeting.
Stuti, can you do it from your side, the unlocking?
Yeah, let me try. Uh,
I
I
guess,
have
Stuti,
unlocked the meeting.
Stuti, we can go ahead with India team and then let Lucy join and they can go next.
Sounds good.
Yeah, so if you could please jump on the India team's slides. Aditya, you're there?
Fast forward.
Yes, ma'am.
Okay, so sorry for the last minute change, but please go ahead. In the interest of time, I would like to get all the presentations started.
Can I start?
Yeah, Aditya, you can get started.
Yeah. So, hello everyone. We are Team Insiders, which was led by our India chapter lead, Soumya Moni ma'am. So, I was the team leader, Aditya Kumar. Our team members are Riddha Shah, Adil, and Ariana. And our team rank was 225. Next slide. Yeah. Yeah. So, here is our team. Aditya Kumar, Riddha Share, Adil Dayar, Ariana Ganguly, and our India chapter lead, Soumya Moni ma'am, and our faculty coordinator, Dr. Vijayata Khare ma'am. So this is the challenge overview already covered. Basically, we have to make a multifunctional model uh, to determine the ADHD diagnosis and the female, whether female or not. These were the submission format, participant ID, ADHD outcome, and sex female or not. So what was the approach we used? Uh, we we have done data cleaning and pre-processing, feature aggregation, target-wise model design, regression, we use regression and classification both. Two-stage we use two-stage modeling, cross validation, threshold optimization, and so first starting with the we have training data and test data. We lo- uh, uh, we use the data connect behavioral data, categorical data, and functional connectomes. Then we move to the pre-processing part where we fix the missing values using iterative imputer with Lasso CV8, and then we normalize the feature and scale the feature using robust scaler. Then we move to the features selection and aggregation, where we have to select and aggregate psychometric features like APQ, SDQ, and we limited our features to 15 robust features aggregate, uh, and reduce. Yeah, we reduced our features limited to 15s, like approx 15s. We dropped the non-used and non-used inputs, that is based on the location and all. Then we move to our two-stage modeling. In first stage, we predicted sex female using uh, LGMB regressor. We use the eightfold CV techniques to smooth our probability, and the outcome of stage one was sex probability, which we used in the further stage. In stage two, we predicted ATSD outcome using XGB classifier. Here we use the earlier output sex probability and interacted with the features like SDQ and SDQ features, and created different boundaries for that. Then we move to the model training, and yeah, then we move to the model training. Here we use the eightfold cross validation techniques and additional one fold for pseudo label for test data set. These models were not much accurate. We tested different things using classifier and regression. Uh, we used the classifier and regression. Then we try to optimize the model as much as possible as alignment to the problem statement. Then we determine the threshold and optimize our threshold. Basically, uh, binary classification defaults at 0.2, 0.5, but due to the imbalance, data and clinical priorities require better calibration. So we use the grid search technique to optimize our F1 score, uh, uh, and especially for the sex female one and ADHD one. Then we assembled and done our final prediction, and uh, uh, analyze our result. So these were the top 15 features which we used for both sex prediction and ADHD prediction. What are the challenges we faced due to the overfitting of the different inputs? Yeah, what were challenges we faced? Overfitting with the high dimensional data, threshold sensitivity, calibration drift, and limited knowledge in the domain. What was the experience? Yeah, what was the experience from this? What we learned from this hackathon? We used to we learned about the light GBM and XG boost tuning by different combination of classifier and regression classifiers. We learned about advanced pre-processing techniques using iterative imputers. Uh, we learned about cross-validation strategies, balance CV, and all. these were our result. Our submission, our two best submission score 0.75463 and 0.75655. Our team rank was 2 to 5. Yeah. What are the conclusion? What outcome did we get from these hackathons? So we learned about to work on the real world medical ML problems. We learn to use the regression with calibrated proper probabilities uh, because sometimes classification doesn't work. Uh, Despite of having a limited domain knowledge, we worked on the data centric part and tried to solve the problem by that. That's all from our side.
Thank you. Thank you so much, Aditya. Very unique solution, I must say. I think your team has the highest score out of all the teams here. So, really good to learn about the solution you've implemented.
Thank you so much.
I think the next team would be the brainstormers. I think we have Aya here, so you guys can get started now.
Hello, everyone. We are the brainstormers. Our team consists of me and Lucy, who are currently attending UCLA for a master's for the master's in data science. Niati and Mansi who are both data scientists. Can you please
Slide?
change? Yes, please. Oh, wait, is it? Oh, sorry. Maybe my. Oh yeah, sorry.
that's
My
okay.
internet is. No, you're good. Oh, can you go back a slide? Because I think you missed one. Oh. Well, we also have Shri, who is our technical lead, and Anat, who was our hackathon lead. I'm not sure why their picture is not showing, but that is okay. So in order for us to solve the problem of predicting sex and ADHD, I'm sorry?
No,
Oh.
you can continue. You can continue.
Okay. Yeah, so the process of how we approach this problem is first we pulled the data from the CSV files that were given from Women in Data Science, and we merged the data sets using participant ID as our primary key. And then we also we then proceeded to continue with explanatory data analysis, where our first step of our EDA was analyzing the null values and seeing if there is a pattern in the missing values. We also analyzed the distribution of the variables and made some contingency tables. And lastly, we tried to find if there is any correlation between the variables. And now we're going to be proceeding to talk about some graphs that we made for the missing values.
Hi. So I'll talk about some interesting challenges we faced with regards to the data. So the first challenge was, of course, like the imbalance in the data. Since this is a women in data science competition, the focus was more on identifying ADHD among female participants. So there were two variables that we had to find. And as you can see, the distribution of the target variable, women with ADHD, the population is actually much less as compared to male participants with ADHD. So there were some interesting techniques that we used to address this class imbalance. Another thing that we had to focus on was missing data. So the age was missing for a lot of participants. There were some cases where ethnicity and race were missing. And there were also cases where the education and occupational details of parent 2 were missing for a lot of participants. So one interesting thing that we did was like instead of treating all of these as categorical variables, we actually used some of them as numerical variables because we believed that some variables actually had some sort of ordering to it. And we did not actually encode them when we were feeding these variables into our model. Next slide, please.
Hi, I'm going to talk about how did we go about with the data pre-processing. So we had all the input data and we knew our goal, but were we ready to build a model? Not yet, because we were dealing with the messy real world data. So there were two major challenges that we faced at this stage. Our training data had 20K features per individual, mostly from the brain scans. So this is what we call the high dimensional data, and it can make the model overfit. To fix this curse of dimensionality, we used something called as PCA, which is Principal Component Analysis, a method that reduces the number of features while keeping most of the information. So here we kept 95% of the variance, so we wouldn't lose the key signals. Second, we had to deal with the missing values. I guess a lot has been talked about the missing values over here. So some data fields were incomplete. For numeric fields, we used iterative imputation, which fills in the missing values while learning from the rest of the data. But for the categorical fields, we used custom fill strategies because we use the custom fill strategies based on the type of variable, because a single approach wouldn't work for everything. We also used a strategy called mice to fill in the missing values. Can we move to the next slide? Shri will take you all through the approach that we took.
Yeah, can you hear me now?
Yes, we can hear you.
Yeah, sorry, I was on mute. Sorry about that. Yeah. So I'll just walk you I'll walk you pretty quickly through the modeling process we did. So we had an overall outer loop that did like stratified cross validation, and we stratified on the ADHD gender outcome combination. So obviously the women with ADHD combination was like severely lacking in our data set, and we had to kind of boost it up in order to get a decent result. So within this loop, we started out with SKLM pipelines to perform like feature engineering and feature selection. We did PCA. We used PCA. We used, as Niyati mentioned, we used mice, which is basically linear regression within the iterative imputer. Uh, so after that, what we did was we also used two very important techniques, which I believe like help boost our score. One of them is important sampling, which is often used in Kaggle competitions, and the other and one which really clinched our score is this mode basically, which is we oversample the women and ADHD combination. Yeah, so after that, we within this stratified K4, we used grid search to kind of perform model selection. So we tried a bunch of different models. So we did like tree-based models. I think they were the ones which really sealed the deal. But we did XGBoost, LightGBM. We did support vector classifiers. We did ridge regression, and we also did a method based on Riemannian geometry where we used the distances between the manifold distances to kind of get the classification output. Yeah, and after this we did like out of fold predictions on both the train and test data sets. So these were like pretty critical. So what we did is outside this loop, we did an ensemble, and these out of fold predictions like they kind of went into the second layer of models. Yeah, so we use these out of fold predictions from XGBoost, LightGBM, Logistic, and one more support vector classifier, I think. So we built a max word classifier on the out of fold predictions, and that was our final submission, and ultimately our final score. Yeah, so that's a brief walkthrough through our modeling process. So I think you can move on.
Yeah, and then to quickly wrap up, so our team coordination, we had weekly meetings where it was really helpful to share resources such as our code, our notebooks, and domain knowledge that we read about. Next slide, please. And with our weighted F1 score, our final rank was 446th on the leaderboard. But more importantly, we had a lot of takeaways after this project. On the non-technical side, we learned to work together and utilize our individual strengths, as well as how to delegate tasks in a team setting. For the technical side, we learned how to deal with high-dimensional data, which we hadn't experienced before. And also in general, this just sparked our interest in research in women's health, and allowed us to experience different types of data, such as the MRI data. Thank you so much to Women in Big Data for giving us this opportunity.
Thank you so much, brainstormers. Really, you guys nailed the key problem, which was data processing and smooth and imbalanced data set. I think, yeah, you guys did amazing. Thank you. Thank you for sharing. I think the next team we have here is going to be the Data Divas. So, Data Divas, you're on next.
Hello, can you hear me?
Hi, yes, we can hear you.
Okay. Can I start? Okay. Hello. We are Data Diva, and I'm Anne, and we have Jasmine here representing here today. And for our team, we have two mentors. First one is Rafi, who is a business and product strategy consultant who have extensive knowledge in data and machine learning. The second one we have Fadia, who is now a software engineering manager. And for our team member, we have Jasmine, who will be presenting later. She is our team leader and also a data enthusiast. And I'm Anne. I'm a front-end developer. We also have Vicky, who is currently doing a master in supply chain management in the University of Sydney. There's two fun facts in our team. First one, all of our team member is a participant in the data camp Donates. And the second one is we are in two different time zones. Like me and Vicky is based in Sydney, and the rest is based in US. Next slide, please. Like Studi do a brief introduction on the problem statement. So the goal of the project is to investigate how a machine learning model perform when we try to predict ADHD and gender from the data sets provided. Next slide, please. So there's three main challenges that we're facing. We are all pretty new to the field of machine learning. Like the data camp, the NAID started at the beginning of this year. So all of us is pretty new to data and machine learning. So we don't know how we're going to start the project initially. But the women in big data provided the sample code and will be able to pivot into trying out different machine learning model throughout the program. And with the guidance from our mentor Rafi, having a weekly meeting, and he teach us a lot of advice and skills on how to apply that into the data set, which lead to our second challenge. Is our team is based in two different countries, Australia and US, and they do have a pretty big time zone gap. So it's kind of difficult to organize a meeting, but we try to have a weekly meeting throughout the 8 weeks of time. And we also use different collaboration tools like Google Colabs to share our code. And we try to update our progress on Slack from time to time. And bring us to the third challenge, which we don't have that many domain knowledge on medical field. So it's kind of confusing to see the relationship between brain activity pattern and the variation among gender. And for that, we have a lot of workshop and resources provided by women in big data. And through those resources, we'll be able to understand what do the data set mean and apply them into the machine learning model. And I'll pass on to Jasmine to talk more about the machine learning model.
Thank you, Anne. So our approach to choosing the right machine learning model was systematic and tailored to our multimodal data set. After cleaning and processing our data, we implemented a rigorous feature selection process. We ran this feature selection process separately for each of our prediction tasks, one's targeting ADHD outcomes and one's targeting gender classification. This allowed us to identify the most statistically significant features for each specific prediction task. Looking at these ROC curves, you can see when we then evaluated multiple machine learning algorithms on both gender and ADHD prediction tasks using our selected features. For gender prediction on the left, we see we achieve relatively consistent performance across models with AUC values ranging from about 0.68 to 0.73. For ADHD prediction on the right, we see a more varied performance. We tested logistic regression as our interpretable baseline, along with gradient boosting methods like XGBoost and LightGBM that can naturally capture feature interaction that our feature selection method would have missed. Based on these initial results, we focused our hyperparameter tuning efforts on the most promising models to optimize performance. If we could go to the next slide. So after evaluating all our models, we moved to the final validation step, which is submitting our predictions to Kaggle to see how they performed on unseen test data. For comparison, our logistic regression baseline shown in the second submission achieved scores of 0.70. While these are respectable results for our interpretable baseline, the LightGBM model performed better. So our decision to explore more sophisticated methods was reasonable. The gap between our baseline and the best model demonstrate that the complex feature interactions in our multimodal dataset benefit from the advanced pattern recognition capabilities that gradient boosting methods provide. So these Kaggle scores give us confidence that our model has successfully learned meaningful patterns for ADHD and gender prediction that generalize well to new unseen cases. Next slide. So coming to the final leg, which is the key insights and takeaways. First of all, the whole experience has improved our understanding of machine learning and its application in solving real-world problems. Secondly, the power of collaboration. Our diverse perspectives and brainstorming sessions led us to create solutions that wouldn't have been possible individually. Our complementary skill sets, where everyone brought their strengths and expertise to work towards a common goal, made a huge difference. Finally, our iterative improvement approach was crucial. Through regular feedback loops and our willingness to experiment with multiple algorithms and feature selection methods, we continually refined our model and improved performance. This taught us that machine learning is more about systematic experimentation than about technical implementation. And I'd also like to thank everyone in Women in Big Data for giving us a platform to test our skill level and also share our learnings. And also huge thanks to our mentor, Ravi, and also to Srividya. Also, I thank all of you for listening to us share our learning experience today. Thank you.
Thank you, Jasmine, and thank you, team. Really impressed by how you guys managed working across time zones and keep up the weekly meetings and the schedules to complete this challenge. I think really kudos and great teamwork, really. Next team we have is the Bay Brains team here. So Anoop and Winnie, if you're on the call, you can get started.
Yeah, Winnie will be doing the introduction. Go ahead, Winnie.
Okay, next page, please. So hi, we are the Bed Brand, and the team members Alyssa, me, Winnie, Emily, and Lee. But I would say our team will be probably like most of us doesn't have much experience about the machine learning. Emily has more experience about the data science, and Alyssa working as a software engineer. Me and Lee, we both are the data analyst. So for us, took us a while to for this, the purpose of the challenge, we tried to just really learn about machine learning. That took us a while to really learn about like how to tackle the problem. And next slide, please. So at the beginning, we actually talk about, are we really going to do this topic, or we kind of have like a late start. So are we really going to do the same topic, or we want to do something like start our own topic? So that took us a while to like really start to dig into the question. And next slide, please. So like I mentioned, because we don't have much experience, so really thanks to the Anoop to help us set up the GitHubs, like a Google Collab, try to have like a weekly meeting, work together. Also, thanks for the Women in Big Data, provide the workshop resources that really help us to understand the topic. And next, we will have the Anoop to talk about our process.
Yeah. So yeah, we can jump to the next slide. So I'm really proud of the team since nobody had really much experience in data science and machine learning in general. They were always very interested in learning, and I think we did a great job in that sense, right? So initially, as we start every other project like this, which is very vague and we have lots of features, we started to tackle the whole problem of feature selection. So this was like a good learning point for most of the team. We separated the team into two parts where a bunch of team members would look at a specific set of features and the other set would look at the connectome features. So while going through, we noticed that the distribution of the MRI scan by age is really lopsided, and then you have different enrollment years as well. So we decided to kind of you only go for the central, I guess, parts of this data spread and work with those. So please, next slide. Uh, no, next slide. Is this? Oh yeah. Okay. Cool. So the previous one is fine. Yes. So initially we said that, okay, let's now work with the data that we have with the selected training data that we have. Similar to most of the other teams before us, we tried the Innova F test where, we tried to calculate the statistical significance to find the top features that we would work with. But eventually, I think, it started to get too new for a lot of folks to learn. So we fell back on a more traditional or a more simpler approach of reinforcement learning and random forest. So the way that we did it was we used random forest for feature selection, where the goal was the F1 score, and then we would want to try it with a whole lot of different features as we went along. And before we did that, obviously, with the set of features that we had all decided, we, imputed all the missing values, went through over the categories, and standardized all the features. We did the whole same PCA component analysis and everything else to reduce the dimensionality, etc. With many of these, we basically played around with different feature selection methodologies, and we did that separately for the behavioral assignments. We did that for the age factor of like the metrics based on age, and then also the APQ features as well. Going over, we also went over the connectomy data. So can you please go to the next slide? So with all of this, we wanted to look at it in a more visual manner, so as to make the decision. So we created these pair plots for the different features. The first one, which kind of showed and kind of educated the team that you can see clear patterns and clear clustering between the red and blue points in distinguishing ADHD from non-ADHD cases, and which features are probably more reliable indicators of ADHD versus not. And similarly, on the right hand side, for some of these selected features that we have, we did the correlation heat map as well to understand how these selected features actually correlate with each other, and analysis of or the outcome of being ADHD and also in the gender of female. Next slide, please. So we did the same as well for the brain components with the same analysis that we had. And out of this, what we had was we noticed that the brain connectome features and were mainly the dominant features in our selection feature set. And there were like 2 or 3 SDQ features which we also included. And when we did the same with the connected heat map, we would also see the same kind of outcomes. So if you go to the next slide, we eventually ended up with these 3 SDQ features and these 3 brain components, which we felt were the most reliable factors determining ADHD and female. We tried this out in the initial applications and it gave us really promising results. I think somewhere close to 0.7 and 0.8, and we were really happy. But then something that we learned really late was that the training data which we were training on was also had a data skew, I believe, and we didn't really try again. And when we submitted it, the score obviously came down because these features weren't actually as reliable as we thought initially. So that was an interesting and good learning that we had. If you could go to the next one. We ended up with a rank of 751 and a score of 0.65 across all of our submissions. And the next slide. Eventually, we'd like to thank Women in Big Data for the opportunity. It was really interesting because we keep hearing about data science and machine learning, but it was very interesting to jump into it. And the team was really, interested, and they really made time because even in our case, they were spread across the time zones. So they made an effort to create like a WhatsApp chat and also converse over email and across time zones and share ideas and collaborate. Also, a big shout out and thanks to Anat for giving us a lot of resources when we needed them and kind of keeping up with us because it is very easy to get boggled down by something that is new and difficult, and keeping us on the track and really helping us finish was something that she did and helped us all out. So overall, very great learning opportunity for the team, and it was a pleasure. Thank you so much.
Thank you. Thank you, team. Really proud to see all the progress and the growth from all the team members here. And thank you, Anup, for all your technical expertise and guiding the team through completion as well. So, cheers and congratulations on completing it successfully, and at least all the work that you've done. Really amazing as well. I think the last team we have here is going to be Team STL Miners. Unfortunately, they couldn't be here. So, Rupa, can you talk to the team's progress and their efforts?
Sure. So this is our team STL Miners. Unfortunately, they cannot be here today, but nevertheless, we have our awesome team from St. Louis chapter of Women in Big Data. Usha Ramlingam is our Women in Big Data St. Louis chapter director, as well as she is the director at Data Compliance Platforms at Mastercard. So she also mentored the team as well as being the chapter hackathon lead for St. Louis chapter. We had Zian Zhao, Jayant, and Justin, all 3 students from Washington University, spanning like all time zones and states across US, from Washington University at St. Louis to Purdue to Kansas State University at Salina. Justin joined us from there. And the team started a bit late. They had commitment and their school-related conflicts. But finally, they came together, they worked really hard, and this is, can you please go to the next slide? This was their final score, a rank of 740 out of 175, and the final submission score, the final submission that Zian made, and she also took on the additional responsibility. She stepped up to help Usha, and also extended the mentoring and leading the team to complete the challenge. So their best score was 0.73, and the rank, as you could see, is 740. This was their final score. Unfortunately, we do not have their learnings and key takeaways, but what they have shared along the way over last few weeks, everybody joined with little experience of working on real world data. And this challenge, this platform through Women in Big Data's Hackathon cohort gave them, a lot of exposure and experience to, learn as well as deliver their spectacular result, being worked on it, a challenge like this for the first time. So I'm very proud of our STL miners from St. Louis chapter. Congratulations to all of you.
Thank you, Rupa, for covering for them, and glad to see all the progress all the teams have done. So I'm really proud to see all the solutions and all the final rankings here today. With that, we can dive into the Q&A. Anyone has any questions or any comments?
Even like, anybody can share, ask questions to other teams, or if you want to share anything, the chapter leads, Soumya, Anath, um, uh, feel free to comment, or anybody, any team member, if you want to talk, ask other team members. Yeah.
I'm sorry to cut you off. I just had a. So, will you have a competition next year as well?
I'm
So,
sorry. What is next year?
No, will you have a similar setup or a competition?
Yes, absolutely.
Okay, gotcha.
So we will be planning another cohort this year, sometime in fall. Um, the nature, the scope of that cohort would be slightly different. It may be different from what you have done in this cohort. So that's one. We typically also try to collaborate with startups, or some companies from a particular industry, a domain, and we kind of assemble the challenge working with that startup. So that would be the general nature of our next cohort. But again, at the end of the day, you would be solving a machine learning AI problem, using all your skills, related skills in this field. And a very similar structure, similar cohort with Kaggle, in partnership with Women in Data Science, would be early next year, similar to either winter or spring hackathon cohort in 2026.
Thank you.
Rupa, this is Soumya. I have sent a message as well on the chat. Thank you for the opportunity for the India team. I know this is our second hackathon participation. We are really happy. And I was happy with the team contribution as well. One question as I was going through all of the presentations was, did any of the teams notice an inherent bias in the data? Given that I know one of the teams mentioned that this was for women in big data, so they were looking at more women or female representation with this diagnosis. So I was just wanting to know if did they notice any inherent bias, and if they did, how did they resolve that bias? Any of the teams can answer that, actually.
When you say bias, could you kind of talk more about that? Like, what do you mean?
Yeah, so one of the teams mentioned that a lot of the data categories were missing. And did they assume some of those categories that were missing, either probably the location, the geography, the ethnicity? And they mentioned that they used some proxy for that. So wanted to know that, yeah.
I think from our experience in our team, I think there were a bunch of there was a subset of data where data wasn't missing at random. There was clearly a pattern to it. But I think for the most part, I think especially after the correction, right? I think that they just I didn't really we didn't really notice any bias. We also tested it using we used a bunch of techniques to see if there's any bias or if there's any importance specifically allotted to a bunch of data points. I think our takeaway is that it was a pretty noisy data set owing to the dimensionality. And apart from that, I could be wrong, but we didn't notice it.
Okay, thank you.
Yeah, and I think the videos that Women in Data Science put up, right? They had like a series of workshops. And in one of the workshops, they mentioned that, maybe you should use location when you're stratifying data and using cross-validation because there might be some bias because of that. So we tried a couple of those things, but I don't think it impacted our analysis that much.
Okay, thank you. Thank you, Mansi.
I also want to comment, the presentations were really great. I learned so much from Jasmine, Aditya, Anup, Anna, Winnie. So really great presentations. And the structure is amazing. For someone like me who's very new to this field and still learning, having a mentor, having teammates, and having someone like Anath on us telling us what's up, when are you submitting, when are you doing your first submissions. That was really great. So kudos to the Women in Big Data team and looking forward to such opportunities.
Thank you, Mansi.
Thank you.
And what can I say? Maybe I'm already biased, but that's why Anath is great.
And special shout out to our team leader Shri for helping. Absolutely. And all the team leaders actually for mentoring all of us. So thank you so much.
I want to mention that in the event that we had this weekend in the Bay Area, we had Lightning Talks event, and Niyati was able to present about this topic, her own view and her own focus. And it was great, and it was very interesting and very enriching to our event. Thank you.
Awesome. Very nice. I guess I know it is already late for many folks, and probably have one last question or comment. Anybody? And don't worry, we will be, if you want to connect with members from other teams, feel free to connect with me and Stuti. We will be happy to connect you and share their contacts so that you can connect across the other teams as well. All right, so I hope you have got a little glimpse into the world of women in big data, what we do, what we offer, and we are here for you, with you. And we would like to welcome you. If you are not already part of Women in Big Data, please join us. There are multiple opportunities, different types of opportunities that you could take part in to get associated with. And with that, I would, next slide, please. This is, my favorite slide. Every time I would like to just give a call out to all of you to please join Women in Big Data community. We would love to have all of you. And this is it's a partnership. We want you, and you can do a lot of work in the sense when I say work is learning, contributing, connecting, and also giving back to this wonderful community at Women in Big Data. We have presence in pretty much all the social platforms. So if you could please go to the next slide. We have dropped some of the, last slide, be part of the solution, be part of this organization, this wonderful initiative that we have here at Women in Big Data, as well as our sister organization, Women in Data Science. We are planning to bring more, exciting programs through hackathon, through mentoring and other training, technical training initiatives to the community. So these are multiple ways you could connect with us and be a member. Next slide, please. And I think that's what we have. That the last slide. Yay, thank you. So we are at the end of this session. Thank you so much for joining from around the world, different time zones. Thank you for staying up late today. It's the weekend. Really appreciate your time and spending last 3-4 months with us, and hope to see you all again soon with our next cohort or any other programs and initiatives at Women in Big Data. Let me know, connect with me and Stuti either on LinkedIn or through you have our Women in Big Data's email IDs. If you want the slide deck or would like to learn from other teams' presentations, please connect with us and we would be happy to share that. The last note on this, we will be sharing a blog and the link to the recording of today's session. Feel free to share it with your network, have it for your archive, and you could always connect with me and Stuti if you have any further questions. So thank you so much. And we wish you all the very best in your data science AI journey. So stay connected. Good luck.
Thank you, Rupa.
Thank you.
Thank you.
Thank you, everyone.
Thank you.
Have a nice weekend. Bye.
Bye.
You too.
Yep. Thank you.